Hello, welcome to the latest episode of Data Unchained. This is our Supercomputing 25 edition. So we are broadcasting live from the St. Louis Convention Center at the largest supercomputing show of the year. And this week we're focusing on not just high performance, but also data access and data use. Today's guest is probably familiar to a lot of you. Ari Berman is no longer with Fireteam, and I'll try to not make that mistake, but was the founder and CEO of Fireteam and with them for quite some time. Recently joined Starfish. So Ari, welcome to the show.
Thanks. It's good to be back.
Yes.
We did this a few years ago.
I know, but now we have to talk about something a little bit different.
Yes, we do.
So Ari, tell us about your background first, and then a little bit about Starfish.
Okay, great. Yeah. My whole background has always been about bringing science and technology closer together. So my background is both science and technology. I'm a PhD in molecular biology and trained as a neuroscientist. Did 15 years of laboratory research in brain diseases and 5 years of purely computational research, trying to bring those different areas together. And at the same time, I've been designing, building, and operating HPC systems for science for about 30 years. And so my whole goal has always been to bring technology as a supporting player to make science go faster, to make the world a better place, essentially. So
you're one of those unicorns that knows the science for real and can run a supercomputer. So that's a very unique skill set.
I used to be able to. You said I was CEO of Fireteam for a while, which means I was really chief PowerPoint officer. So, you know.
Yeah, I used to be able to run an Oracle database too,
yes,
and
did.
I wouldn't touch one now.
I would touch it. People would get mad at me.
So Ari, tell us about Starfish. You recently joined the company. They certainly have a tie to the life sciences space, so that makes sense. I know they do more than just life sciences, but tell us about the company and a little bit about their customers.
So Starfish is essentially an unstructured data cataloging system at its core that can go out. It sits adjacent to any storage systems you have, can scan those file systems, create a very rich data catalog of everything that's on there, make it searchable, discoverable, analyzable, and then you can take actions on it. You can run jobs on those data, like set data lifecycle policies, for instance. If you have to retain certain data, but it's fine to be off in like deep archive somewhere, you can set that up on certain rules, and you can do rich metadata tagging with it, and you can also have it kick off jobs in places. People use it to calculate the cost of storage per file, things like that, and help with chargebacks and showbacks for end users, and then just to really optimize how things work. And there's some user space activities too. You can set up zones for particular areas like projects or particular directories that give the end users some power to tag their data that can take action on. So it's a pretty powerful system.
So this morning you were on a panel with the guest I just recorded with William Baird from Garden Health.
Yeah.
What were you guys covering on that panel?
Well, it was the NVIDIA Innovation Breakfast.
Ah.
So it was about innovation in AI and infrastructure supporting AI. Of course, we brought it back to science, both Will and I. And Glenn Lockwood from VAST was also on. We really were talking about, at some point, HPC actually needs to become a service more than just a cluster sitting there, and abstraction away from the end users so that they don't have to care what they're running on, it just runs. This has been something we've been talking about for a long time, but the canonical HPC nerds are like, no, we've got a thing. It's got to be the thing.
These two cultures of the AI and the HPC people are a little bit different in some ways.
They are, but it's forcing everyone to grow up a little bit. I think AI is super overhyped, but I'm not quiet about that. I think it's super useful. I think that there's a lot of good things that it's doing, but I think you need to understand what you're doing. But what it is doing is forcing everyone to grow up in this space and try different things.
So let's talk about data in this context. So whether you're doing HPC or AI, whatever it is, access to data is super important. One of the big challenges is data's been created in a lot of locations by a lot of different people over a long time. So Starfish initially really helps. One of the kind of key tenets of what you do is just know what you have. Talk about that a little bit.
Yeah, traditional POSIX file systems are really bad at telling you where things are. Because to query the file system, you have to list the directories, or you have to do an extensive find or something. There are some databases you can scan in Linux and things, but the various different file systems all do it differently. So what this does is allow you kind of a single pane of glass that operates very performantly and can catalog many hundreds of billions of files and many hundreds of petabytes of data in a self-contained system that doesn't directly affect any of the operating systems. It's got agents that go in and scan.
So it's out of band.
It's out of band.
Yeah.
It's outside. The only time it affects the file system at all is when you take action on it. When the system administrators say, okay, this class of things, let's do this with.
Okay.
But otherwise, it's just outside. So a lot of discovery, a lot of analytics, a lot of life sciences organizations might want to know, how much human genomics data do we have on this file system? How much do we have in our entire organization? NIH is asking that question right now. No one knows. No one knows how much storage they even have. But something like Starfish can help you do that.
So it makes data knowable, findable. You can also do things like Chargeback. Talk a little bit about that tool.
Yeah, that's right. So it has a whole analytics system on top of it that's built on a system called Redash. It has a very rich graphical interface that you can ask all sorts of questions of your data. The Starfish system has a metadata extractor as a part of it that for a lot of different types of data can go in and read the headers of files and pull that out and automatically assign that. And if there's types of data that are not common, we can work with you to do it custom. But one of the cool things about it is that you can say, okay, this is how much the file system costs to build. Here's how much it costs to run. And then the system can automatically abstract how much it costs per gigabyte, per day, per month, per whatever, for X number of things. Then you can go to your bad actors in the organization and say, you're costing the organization $3 million a year because you don't delete stuff. Let's delete stuff. And so there's, you can do shameback, you can do chargeback.
Shameback, that's a term I've not heard, but makes a lot of sense.
It makes a lot of sense, yeah. Good data citizenship is hard to mold in environments where everyone thinks, the storage is free.
So when you think about that, decisions about data and how it's going to be used, in a lot of cases, in HPC, for example, people kind of held on to the data. They wanted to kind of keep it on their machine and their home directory. But there's a world where we need to share it. We have too much. We have to manage it better. How do you kind of get involved in the space of, is it user-driven decisions? Can administrators make decisions there? Is it a little bit of both?
I have some strong opinions on this, which should surprise you.
You tend to have strong opinions.
I'm not quiet. So I think, in the past, at least in life sciences, I'm going to go with life sciences. Life sciences, maybe the worst data citizens on the planet, I would say. They really are just like, I just got to do my stuff and get it out.
My research,
exactly.
Just hang on to it and get my science done.
No one can see it because someone else is going to steal my idea.
Write the paper, get published.
All of that.
Yeah.
And then I know this outdated thing that I have to keep the data for 9 years, and that's not even true anymore. But so the issue really is that up until now, system administrators, storage administrators, have been forced to do the data management for the scientists without any context of what the scientists are doing. They're just like, you have a lot of data. You cannot have a lot of data. Go delete stuff.
Right.
And with no prior knowledge of what they're trying to do.
What it is that's in there. Right.
Exactly. Which says that is implicitly the wrong way to do things. The system administrator shouldn't have to do this. If you are a scientist that's generating data, you must manage your own data, which means you can't just be like, oh, it's over there, I don't have to worry about it. You need to understand what it is. You need to record it. You need to have some idea of the quality of your data. Don't just save everything because you think it's free. You have to do something with it. So you have to manage your data. And most end users, at least in life sciences, they don't really think about that. They're like, oh, I've saved it, keeping it forever because we hoard everything.
Right. And then there's kind kind of the other end of the trajectory where you can make automation, where
Yes.
maybe the scientist gets to keep everything, but automatically it gets into some cheaper storage, or automatically someone else can find, like, oh my gosh, this file has the data that's going to help me on my project.
Correct.
And so there's some things there on data sharing and data movement by putting them into global systems. Having global file systems can be really helpful.
Oh, super helpful.
How do you think about the benefit of that?
So I think you just had Will from Gardent on here,
Yes.
and they're kind of piloting this generalized single namespace idea precisely for this reason. Large global organizations struggle with data being produced all over the world and needing to take advantage of the value of those data in an actionable way for those organizations. Gardent, how many cancer diagnostics can we do? Can we help people stay alive longer? Do we have those types of things? And other pharma companies are, how do we get stuff into our drug development pipeline? How do we get diagnostics working? Those sorts of things. And then for research organizations, it's the same thing. How do we discover? And it turns out that one of the fundamental tenets of science is collaboration, which means that assembling data from lots of different places and analyzing it in a single context is very, very powerful. It used to be called meta-analyses. I don't know what it's called now, but it shouldn't be. I think it's just analysis.
I always think of meta as something else. So
Right, exactly.
I don't know, but yeah, your point though is that having the ability to do that is really important.
It is really important, and different storage systems cause silos of data, and so de-siloing data de-silos organizations, de-silos the capabilities of discovery within an organization, of utilizing the investments they've made to generate or buy those data and do something useful with it.
And that's certainly part of, I'm here as the Data Unchained host, but I do represent Hammerspace, as we all know. And that's where some of the synergies and partnership come from, is our global data platform and global file system hooking into your catalog and making everything have the ability to read, write, be shareable, move it to some compute when you need it, have the performance you need when you need it, or the low-cost storage when you need it. Kind of the two fit really nicely together.
Absolutely. I think our missions are the same. I think people mistake us for competitors. We're not. We actually.
That's the reason you're on the show, and because I like you.
And I like you too. And I think that there's a lot of good synergies here. You all create a real global file system. It still could be analyzed and action being taken on it by our system, which sits outside. And then the two could talk to each other more directly. And so we're discussing things like that. And I think that having a global namespace within an organization, globally even, which I know is something you guys do, is really helpful, especially with legacy storage systems that people have, 3 or 4 different vendors, and end users just want to look at it in a single context. System administrators want to manage it in a single context. I think both of our tools are trying to accomplish that, but in very different ways, which is awesome.
And we talked a fair bit about life sciences today, and it's one of the more difficult industries for a variety of reasons. Long-standing habits of doing things a certain way. We talked about data control. There's a ton of data.
Yeah.
But you guys work in other industries, and I think it's worth talking about that because other industries have different requirements. Like government has certain security rules, and maybe just cover a little bit about other industries that Starfish is really active in.
Yeah, so it's interesting. One of the reasons I think that I was drawn to Starfish is because they do work with a whole lot of science organizations, and clearly my passion is science. But my passion also is just data health and
supercomputers.
Big shiny things, yes. Because ADHD, but
we all have a bit
we
of
all
that.
have it, right. So we work in a lot of other industries. We work in media, which is, crazy amounts of data, video data, audio data, streaming, cataloging, editing, all of those things. That's not an easy thing to do. They have a much smaller number of formats, and they're way more aligned as far as data structures than, say, life sciences, which is the Wild West in a lot of ways. Mm-hmm. Other sciences, astronomy, high energy physics, those sorts of things. We're in those places. We're scanning El Capitan now, cool. The fastest supercomputer in the world, at least by top 500. And that's pretty awesome because it's just an enormous amount of data. Garden Health uses us. But we also are in other places, agencies we can't talk about, and financial, fintech
So kind of the more rigorous, standardized enterprise government environments. Not to say life sciences isn't. They have their own standards and rigors to adhere to. Patient health or patient privacy, bah.
Sure, yeah. The patient
but not
side
on the
of things.
research side.
Yeah, the research side is... Yeah, there are standards. There's just 45 of them, and no one can agree on which one they should use.
We actually did a show about that one point. Should we have standards in life sciences? And overwhelming answer is yes. And then I asked who should drive them, and lots of shoulder shrugging.
Not me. Right.
Exactly.
Someone else, you.
Exactly. Cool. So thank you for joining the show. I know it's very busy, and you're new to the team over there at Starfish. Almost said bio team again, but I'm not going to do that.
That's all right.
To learn more about Starfish, the website, is it starfish.com or
starfishstorage.com?
Starfishstorage.com. We have, if you're interested about integrations with Hammerspace, we have some joint solution briefs and whatnot. I'm sure that on their website they have some about other workflows and whatnot.
We do.
And certainly, I'm sure Ari would love to hear from you all. Connect with him on LinkedIn and send him a message of why you want to talk with us.
Yeah, we'd love to talk to you, and can't wait to work more with you in this
Great.
context.
Thank you. Thanks for joining the show.
Thanks for having me. This is fun.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.